Hi, in today's video I want to show you how to use YOLOv8 algorithm to detect objects on images and videos. Let's get started. So first you need to prepare your training data. I have here some screenshots of lakes on satellite view, because I want to detect lakes, but you can use whatever object you want. And when we have images, we need to label them, so we need to tell the AI where is lake and where is, for example, forest. So I will use the RoboFlow website to label them. So you need to go to RoboFlow and here roboflow.com. Here get started. And you will have to log in or sign in to this website. And when it is done, you need to create new project. Here you need to choose what do you want, what kind of detection will you use. Object detection is to detect where is object. Object classification is to tell what is on an image. Multi-label classification, I don't know what is this. And instance segmentation is to detect object edges. And so I will choose bounding box. Here I will detect lake. If you are detecting more objects, then you will have to write them here. I will name this project tutorial. And license can stay as it is. So create public project. And now I have to select my images. So these screenshots of lakes. So I can drop it here. And now I have them here. So I need to click save and continue. And now I need to wait some time to upload these files. Now when uploading is done, you have to assign images. So click here. And we have to annotate them. So start annotating. I will wait so it will load. Okay. And now here with this tool I have to annotate every leg on this image. And with this tool I can move around. And when I annotate every leg on this image, I have to click this arrow to move to next image. And you have to do it for every image. So when you have finished annotating, you can see here it's 61 from 61. When I click next, it's first image again. So here I have to go back and add 61 images to dataset. And here I have to tell how many images is to train, set, valid and test. So train is these are images that are to train AI. Valid is to check if it's improving. And test is for us, so we can test ready AI. So I don't need really this, so I can do even like that. And here I will do 20% and 80 and add images. So here I have my data set, and as you can see, these are train and valid images. Here I can say only train and here only valid. And we don't have, we have one test image. So now I can go to generate, and here I can add some parameters to train AI. So resize is to scale image to this resolution, because YOLOv8 use this resolution. Auto orient can stay. Here I can add some steps. I want to add grayscale. Yes. Apply and continue. And I can add some argumentation steps. Rotation. Yes. So these are things that will generate more variations of our images, so we will have bigger dataset. And now generate. So here you can train your model with YOLOv8, but you have to pay for it, and we will do export dataset, and we will train it with Google Colab, and it's for free. Here I have to choose YOLOv8 and download the zip to computer. Continue. And this is our dataset. And now we have to copy it, and I can now unpack it. Now it's here. So I will name it just dataset, and I can delete this. And here we have, I will change the view to this, 3 folders: test, train, and valid. So you know already what is this. And here we have images and labels. In images we have all our images, as you can see, and in labels you have text files with coordinates where are lakes on image, and the same in valid and test. And we have also data.yml file. When we open it, you can see it tells to AI where to search for dataset. So we have path to train, valid, and test set. We also have number of classes. So in this I have 1 class and it's lake, but it may be more classes when you're detecting more objects. And here we have 2 files that we don't need. Now we will train model, and I will use Google Colab. This is online code editor, and we can use here online GPU for free, and this is so powerful GPU, so we will use it to train our model. First you need to choose here runtime, here, and here select GPU and save. And now we have to load our dataset to Google Colab. So here we have our files with which we will operate. We must wait to connect with runtime. Okay, we are connected. So here I will show you. I I load dataset to Google Drive, to folder YOLO tutorial. Here is our dataset, and here I will click this Google Drive icon. I agree, and I will be able to use with Python my files on Google Drive. You can see I have here this folder, and inside this folder I have YOLO tutorial, and here is our dataset. So first we have to install Ultralytics library. So !pip install Ultralytics, and run it. This will install our necessary dependencies, and in next cell and YOLO task equals detect, because we will detecting our legs. You can't left space here, it must be wrote like this. Mode equals train, epochs equals 100, so it will 100 times iterate through our dataset. Data equals, and here we have to provide path to our data.yaml folder, and image size equals 640, because YOLO operate on 640 resolution. And this is all, I think. Okay, so run that. Okay, you can see here that it started training, and all we have to do is waiting. Okay, it finished training, and results are saved in runs folder down here. Here you can see it's telling us they are here in detect, train, and here you have some informations about training. So you can read it if you want. But very important thing is in weights folder, and here is our train model. It's trained 91 models, but this one is the best, so we can download it on our computer. And we have our trained model. So here it is, and it's ready to use. So I renamed it to be just best.pt, and I will move it to new folder. I will name it YOLOv8 and move it here, and in this folder I will create new Python script, and it will just script.py, and I will open it with Visual Studio Code. You can use your favorite code editor, of course. I will open this folder with Visual Studio Code. And you can see we have our model and script. And in this script, first you need to install Ultralytics on your computer, and notice that it works on Python 3.10, not of Python 3.11. So in terminal write pip install Ultralytics. Okay, and when you install that, you can write from Ultralytics import YOLO. And now, when we imported that, we have to define our model. So model equals YOLO and path to our model. It is in the same directory as our script, so I don't have to write full path. And now I will do prediction on it. So I have here some video. And you can see there are some likes, and I will use this video to test our model. So I have it here, and now I have to write model.predict and here 1.mp4, name of my video, image size 640 as before, save equals true, because we want to save our prediction, and show equals true. So this will show window with with prediction, and now I have to run it, and I hope it works. Oh, I forgot one important argument. Conf equals 0. Let's say 8. So this is how sure is our model. If it is 1, then it is absolutely sure that it is lake, and if it is 0, then it says it's definitely not a lake. So let's say it conf it's 0.8, and you will see what it is doing. You can see window. This video is not very smoothly because I chose a very heavy model, YOLOv8X, but you can see some predictions here. You can't see all of this video because I have too small screen to fit it. So, wait a minute. There's no predictions right now. Oh, you can see some prediction, and here we have a confidence. Oh, this is confidence, and I set it to be not to display only boxes that have confidence bigger than 0.8. I hope it worked for you. If not, try to describe your problem in comment section below. You can also learn how to do instance segmentation with YOLOv8, or how to deploy your model so you can use it in your Python application. Bye!